Hello, welcome to this study of partial differential equation lesson. So in this video, I'll take you through how to solve non-homogeneous partial differential equation of order 1. Okay, so first order PDE, which is non-homogeneous. Alright, so if I have an equation like this, how do I go about it? Now let's first check about the coefficient of our ux and uy. You can see that the coefficient of ux is 1, which is a constant, and ui is also 2, which is also a constant. So now once I have something like that, then what I do is I find my dy dx. Always in partial differential equation, we find some equation that can characterize the differential equation given. Okay, so this is equal to 2 over 1, and this will imply that dy is equal to 2 dx. Okay, now once I have this, I have y equals 2x plus c. I have c is equal to y minus 2x, and then I can divide through by -1. I'll get c is equal to 2x minus y. Now once I have this, then since this is non-homogeneous, I need to get another equation that can characterize this partial differential equation. So if you could see, it's like I have some s given by 2x, minus y, and now this 2 is from this b here that is related to the ui, and this 1 in front of the negative y is also from this. So the other alternative function is tau is equal to ax plus by. Okay, so a here is just 1, which is here, and this is our b, which is 2. So I have x plus by, which is 2y. And now these two differential equations, these two linear equations can characterize this partial differential equation. So next thing we need to find is our ux and our ui. Okay, we need to find these things so that we come and put them back in this equation and solve it. Okay, so let's go to our next slide and find our ux and uy. Okay, now my ux here, ux is equal to du ds, okay, times ds dx, then plus du d tau times d tau dx. Okay, and uy will be equal to du ds times ds dy plus du d tau times d tau dy. Okay, and this implies that I have ux equal to what? Now the s dx is what? Let's go and check. The s here, the x will give me 2, so I'm differentiating x with respect to x, and I'll get 2. Okay, I have 2 us, then plus the tau dx. Now the tau ds is what? 1. Okay, I have 1 u tau, so I have like that. Then the u ds times the s dy. The s dy is what? The differential of just y components, and I'll get -1. Okay, so I have negative us, okay, then plus 2u tau, because when I differentiate tau with respect to y, this is what I have. Okay, tau with respect to I have what? 2. Alright, so that is what we have. Now I come back and put ux and uy into our main differential equation, or PD, which is giving us ux plus 2uy ui, then let me see, plus 2x minus y, then equals that. Okay, plus 2x minus y u equals 2s squared plus 3xy minus 2y squared. Okay, now if I put my ux in, ux is this, so I have 2us plus u tau and plus 2 into uy, which is this, negative us plus 2u tau. Okay, then plus 2s minus y is what? Let's go to our previous slide and see. 2s minus y is giving us s. Okay, so plus su equals s tau. Now if I multiply s and tau, this one, if I multiply these two, I'll get this whole expression. Okay, so in other words, just find your x and find your y. Use it from these two equations, equation 1 and equation 2, and substitute them back into the right side of the equation, and this will give you the same thing, s tau. Okay, but you can see that, oh, quickly, if I multiply these two, I'll get something like 2s squared minus 3sy minus y squared, and it means that the product of s and tau will give me that, and it means we are changing the whole of this PDE to s and tau. Okay, so now I have 2us plus u tau minus 2us plus 4 tau 4u tau plus su equals s tau. Now quickly, let's erase the top here and see what we have. Okay, some of the terms will cancel others, and we'll be left with very simple and a very nice ODE. Okay, so that we can use to solve our PDE. Okay, one thing that you should note in PDE is that always you're trying to reduce the PDE to an ordinary differential equation form, so that we can use our ideas in ODE to solve. So quickly, this can cancel this, and I have u tau plus 4u tau, so I have 5u tau plus su, and this is equal to s tau. Now once I have this, one thing that you should notice is that this is a very simple ODE, and we have so many ways of solving this. Okay, let's go by the homogeneous solution and particular solution method. Okay, so we said that the solution u of s and tau, that is the total solution, is equal to u homogeneous plus u particular. I'm coming to explain. It means I have to split this equation here into homogeneous and particular one. So I have to solve for the homogeneous part, and we are saying that the partial the differential equation here is homogeneous if the right side is 0. Okay, so this is it, and then if it is non-homogeneous, it means the right side is not 0. That is what we have here. Okay, so let's solve a case where the right side is equal to 0. Now mind you, the coefficient of u is s. Okay, now once I have something like this, then I can divide through by 5 and get u tau plus s over 5 u should be equal to some 0. Okay, now this is what I have, so I'm coming to solve this ODE. Okay, alright, we have our homogeneous part to be u tau plus s over 5 u equals 0. Now I have to find something that we call integrating factor, which is equal to e to the power integral of the coefficient of u with respect to our variable of interest. Okay, the coefficient of u is s over 5, then the variable of interest is the tau, and this will give me e to the s tau all over 5. Okay, and this is what I have. Now my solution is, what I have to do is I just have to multiply the whole of this integrating factor through this equation. Okay, now if I multiply it through each term, I'll get e to the s tau, okay, s tau over 5, then u tau plus s over 5 u e to the s tau over 5 should be equal to 0. When I multiply 0 by that, I'll get 0. So it means that I have to simply factor something out here. Okay, we said this whole thing, this whole equation is as if you are differentiating this with respect to tau, differentiating e to the s tau over 5, then u should be equal to 0. Now if you differentiate this, you get back this equation. Okay, so I have d of e to the s tau over 5, u should be equal to 0 d tau. Now the reason why I didn't multiply the 0 to the d tau is we are just coming to integrate 0 with respect to tau, and you should get something. Okay, alright, so I have e to the s tau all over 5, and u should be equal to, I integrate 0 with respect to tau, I get a constant, but this constant is in terms of s, I'm capital F of s. Okay, and simply my u, which is the homogeneous solution, will then be given by what? Divide through by e to the s tau over 5, and I'll get u, which is the homogeneous part, is equal to e to the negative 1 over 5, then tau s, or s tau, anyhow you call it, times f of s. So this is my homogeneous solution to the equation. Okay, to this this ODE. Okay, this is the ODE that we have. Let me circle it for you. This is the ODE. Okay, and the homogeneous part is this side, and we solve a solution for it. Okay, now let's look at a particular solution. The particular solution is being found by considering the function that is at the right side of the ODE. Okay, the ODE is 5 u tau plus s u should be equal to s tau. Now the function at the right side in terms of tau is f of tau is equal to s tau. Here this s is a constant, so what you do is that since this is just some constant times tau, it means the actual solution, or the particular solution, should be, we let the particular solution to be a linear function or a polynomial in terms of tau of order 1. Okay, so that we get the function was, we assume that there's some constant a times tau plus a certain constant b that we don't know, so that after differentiating it once, you get you get a. Okay, and you come and put your things back into this equation to find your variables or your coefficients a and b. Okay, now let's go and use this idea, okay, to solve for our particular solution. This is our particular solution that we should find. This is a particular solution we are looking for, so we are coming to find our a and b. Okay, so let's move ahead to the slides that will let us do that. Now we are saying that we let our u particular to be what? A tau plus b, but our OD is 5 u tau plus su should be equal to some s tau. Okay, some s tau. So what we can do is, since we have u tau, means the differential of u with respect to tau, so I have to find du d tau. Okay, meaning I have to differentiate this with respect to tau, and I'll get a, which is my u tau. Okay, this is u tau. Since we are assuming that this is a solution to this equation, it means this, when I differentiate and put it back, I have to satisfy the equation. So I have to put my u tau and my u in place of the equation that is in this box. Okay, I have to find my u tau from this, that is from the particular solution. Okay, this one, from this one, and put everything back in there. So I have 5 times u tau. U tau is what? A. Okay, u tau is a, then plus s into u. Now our solution is that we are saying that we are considering the particular solution to be a solution to this ODE. So A tau plus B, and this should be equal to S tau. So I have 5A plus SA tau plus SB should be equal to S tau. Now let me group like terms. I have AS then tau plus 5A plus SB should be equal to S tau plus 0. Okay. So now you compare coefficients on both sides. See that the coefficient of tau here in the left side is AS. Okay. Let me use the white pen. It's AS. Okay. It is AS. And this should be equal to the coefficient of tau at the right side, and that is S. Okay. So quickly divide through by S and you get A is equal to what? 1. Now the constant term at the left side is what? 5A plus SB, and the constant term at the right side is what? 0. So I have my A is 1, so I have SB is equal to minus 5A, which is A is also 1, so I have minus 5. So I have B to be equal to minus 5 over what? S. Now let me clean here and write my particular solution. Okay, since I have everything perfect here, what I can do is I just have to write my particular solution, and that will be all. Okay, so I have my U particular. Okay, my U particular to be equal to, we're just coming to write the same. We said it is A tau plus B, and my A is what? 1. So I have tau, then B is what? Minus 5 over S. Okay, so there is it. Now our final answer is given by what? Let me write it well. This is what I have for the U tau. Okay, U particular, and we are saying that our final answer is given by, where did I write the formula? We said it's equal to U. This is it. Let me use the green pen for you. It said it is equal to U homogeneous plus U particular. Okay, and the U homogeneous, what did we say about it? This is a U homogeneous. This is my U homogeneous. Okay, and this is my U particular. Okay, so I just have to sum these two and I'll get my answer. Okay, so let's quickly add some slide to it and then write it. So my U of S tau is now equal to my U homogeneous plus my U particular, and then the U homogeneous is what? E to the negative 1 over 5 S tau times F of S plus my U particular also gave me some tau minus 5 over S. Okay, so I can quickly do some adjustments here and say that this U of S tau is equal to tau. Okay, is equal to, I just want to write this part first. Tau minus 5 over S, then plus e to the negative 1 over 5 S tau capital F of S. But note that your tau was given. Okay, let's go back to our slide and see what is our tau, what is our S. Okay, this is what we have for our tau. This is tau. Okay, and this is my S. So S is 2S minus 5, sorry, 2S minus Y, and tau is S plus 2Y. So let's go quickly and add it to it. Okay, so I have tau is what? 2x. Okay, it's x plus y, or S plus 2y rather, then minus 5 over 2x minus y, and plus e to the negative 1 over 5. When I multiply s and tau, you say we have 2s squared plus 3xy minus 2y squared. Okay, then times f of s is what? 2s minus y. So this is very simple. So this is a solution to the PDE u of xy, okay, that we were supposed to solve. This method is what we call the method of coordinate, change of coordinates, and it's very, very simple. Okay, it's very just change coordinates. You see, the coordinates were this s was equal to 2x minus y, and then we change the coordinate that tau should be equal to x plus 2y. Okay, just very simple like that. And we use the idea of the homogeneous and particular solution. When you use this idea, you don't necessarily do much integration. Okay, alright, so thank you, and don't forget to subscribe to my channel. In our next discussion, we'll talk about the solution to this problem where the coefficients of our ux and uy are both variables. Okay, alright.